This is Chip Shop Kit number 12. In this kit we actually have two electronic projects we can assemble. First the bicycle horn and additionally the electronic shocker kit. In this video we're just going to do the bicycle horn and we'll save the electronic shocker kit for a future video. If you've seen my previous video on the Chip Shop kits, you'll know I purchased 3 of these from eBay. This particular kit would have retailed for £5, which is £15 in today's money, or approximately $20 US. I've gone ahead and stripped these kits back to the individual components and cleaned the PCBs, and we'll have a little look inside now and see what we get in one of these original kits. So in here we can see the things are packaged in bubble wrap. If you saw the previous video, you'll know there was a polystyrene insert in those. So I don't know if these bubble wrap was the original packaging, but that's what we've got in this particular kit. This is another one. This one contains the project box, and of course we have an instruction leaflet. Now there's actually a second instruction leaflet in here and a second bag of components in bubble wrap, but we're going to save that for a future video. So let's have a little look at the instruction leaflet that comes with this particular kit. This one's marked 12A because of course this is only one half of the kit, and this is the bicycle horn. There's some details on how we should assemble the kit. A list of components which has 2 resistors, 3 capacitors, 2 transistors and some additional components. There's a nice circuit diagram here, as well as a visualization of the PCB showing where to put all of the components, and I'm sure we'll refer to these as we assemble the kit. The back page of the document has some generic details about the available kits and how to solder. So I'm going to keep this to my side here and refer to it throughout, but I'll put an electronic copy of this up online if you'd like to refer to it yourself. So first let's unpackage our project box here, and we see, just like with the previous kit, we have a nice bright orange project box and it just snaps together. Now you can see on this one there is a small mark, and I don't know if that's soldering iron damage, which is what I attributed it to in the previous video. It may actually just be mouldings. It happens to be in the exact same place. That just may be the mouldings. The kit does have some holes drilled here, which is interesting and might be interesting when we refer to this later and think about how we're going to put our kit in our provided project box. So we'll just put that to one side for now. In our component bag, we have the loudspeaker, which is provided here. It's a 8 ohm speaker at 0.2 watts, and it's quite nice. Let's just put that to one side. And we also have a bag of components. Let's have a little look in the bag and see what we get. So here's the PCB, and as you can see, this PCB was in much better condition than the previous one I cleaned up. And so this one's cleaned up much more nicely. And so that'll be much nicer to work with in a moment. None of the pads needed repairing or replacing. In our bag of components here, we have a variety of things. The first one is a 9-volt battery snap, because of course this is a 9-volt project. And we also have some wires. So I have some wires here. I might replace these with some additional wires I've got just off camera, and we'll see how we get on. Here is the switch for the project, which I think this is quite interesting. You see here, it's actually made of a piece of sprung metal, and this little red plunger actually pushes the contacts together. Again, and then we have these 2 solder lugs here that we can attach wires to. This is quite a neat little switch. If we look through the rest of the components, we can find we have a transformer here. We have a capacitor, and this one is 100 microfarads. We have 2 more capacitors. These ones are, can't really make it out on this one. Can't see where that's listed. So it says 1/50. So is this 1 microfarad? Yes, I think this is a 1 microfarad capacitor. And you can see this one I've actually wrapped in a little bit of pink paper here, a little post-it note. And that's because this particular capacitor is the same. It's a 1 microfarad capacitor, but it's not testing very well. And so I'll show you that in a moment. But I've got some alternative capacitors we're going to have to use. I've also got the 2 resistors that would have come with the kit, the original resistors, and our 2 transistors as well. And these tested fine, but we'll pop them in the tester when we get to that stage. As I mentioned though, the capacitors are not in great shape, so let's go ahead and test those. So I've got my tester here. And I'm going to put the, well, let's put in the blue one first, this one which I believe tested correctly when I tried it. So just put both terminals in, push this down and press start. And here we go, we're getting 111.4 microfarads. So that's definitely just fine for a 100 microfarad capacitor. Let's test this yellow one, which I haven't marked, and have a little look at what we get here. So here we're getting 1,131 nanofarads, or 1.13 microfarads. So I think that's just fine as well. But let's put in this last component here. And this is showing up as a resistor of 212K. So this one's not so good, and so it's going to need replacing. Now, fortunately, as I say, I've got to the side here that I've pre-prepared. And so here's a couple of, hopefully 1 microfarad capacitors. So let's shake these out. And I'm going to go ahead and pop these in the tester as well. So I just need to make sure they go in 2 different terminals, terminals 1 and 2. And if we pop this one in, 860 nanofarads. So not great, these are actually quite low, which is why I don't want to replace just one of them actually, considering the other one's got such a high capacitance. And if I put this one in as well, I'll make sure I get it between 2 different terminals. Let's see what this one comes out at. 911. So there's a bit of a range on these, but I think these will be better if I replace them as a pair. Okay. So let's turn on the soldering iron. Probably should have done that a few moments ago. So it's just got to give it a few moments to heat up. And while that's happening, let's have a little look at our instructions. Well, it says check our components against the list to make sure we can identify each, which we've done. And then we need to insert each resistor into the correct holes on the printed circuit board. Well, fortunately, there is only 2 resistors, and they're both of the same value in this case, and they go in these 2 locations on the PCB. So this is only showing us the PCB from the top, which is a little bit confusing, but we should be able to muddle our way through. Okay. So I figure that here is where we have the first resistor, and here is where we have the second resistor. So we have some speaker wires here that go beneath. Okay, so as usual, I've got my handy tweezers, and I think these were cut much tighter than the previous ones in the previous video. So I think I just need to bend the ends just a little bit. Okay. So I could have bent that just a little more, so I might actually do so just to bring it down a little bit more. There we go. Okay, good. There we go. That goes right in like so. I'm going to pop it around the other way just because I like my tolerance bands to be on the right hand side, but resistors actually can go either way around, so that doesn't matter in the slightest. We have our second resistor here, so let's see how that goes. Okay, and that one goes at the top here. Again, just to keep the band on the same side, we can do it like so. There we go. Those are our 2 resistors. Okay, so I've got some blue tack here that I'm going to use just to hold our resistors in place. And let's see how our soldering iron's getting on. Okay, looking good. Yeah. So that looks pretty good. It's only really one lead that could be trimmed. Maybe this one, but I don't want to unnecessarily trim it. So I'm just going to cut off the very short stub on that one there. Okay. Good. So there are some markings when I flip this over showing where some of the components should go through. These are the transistor locations, so that might be helpful as we go through a bit further. So what's next on our instructions? Note in which direction the electrolytic capacitors are placed, fit them in the position. Check again that the lead is facing the negative sign, the hole marked on the diagram, then solder into place. Okay, so let's go ahead and do our electrolytic capacitors. So we have 100 microfarad on this side, and so that's the one on its own. So let's see where that's going to fit. And I think that's going to go... oh, it's actually on this side of the board. I've got it around the wrong way. It goes around here. And so if we look on the capacitor here, we can see this is the negative side of the capacitor. So that one has to go to the right of the bit of the board here, and our positive lead goes in here. So let's pop that in gently like so. Okay, then just a little bit of blue tack to hold it in place. Now again, I could try and fold these down. I do wonder if I should actually in this instance make a little bit more room in the case. I did have a little bit of trouble with the battery box on the last one, with getting the battery in there as well. And I think this is even a slightly larger board. So in this case, I might go ahead and think about should we lay the capacitor down like so? And yeah, I think that's going to work quite nicely there, actually, and make the board a bit flatter. Of course, the minimum height is going to be determined by the transformer, but there's no need for these things to stick up super high. So let's go ahead and lie these ones down just to make a change. Okay. So here are our legs sticking through. We can follow those instructions and make sure our negative is going to the right, which it is. And then let's solder this one in place. Okay, not too bad. Maybe could put a touch more solder on the right hand side, so let's do that. Yeah, that's a bit nicer. Okay, so we can trim off the excess. And there we have our first capacitor in place. Now, we're going to skip out on these yellow ones here, and we're going to use these maybe slightly mismatched, but newer capacitors in the 1 microfarad position just here in the diagram. And again, the the right-hand side in this case is the negative. And if we look on these capacitors, hopefully we can see this is the negative side of the capacitor, and these need to go to the right. And so it's not actually the right. Sorry, I misread what was going on here, so it's important to double check. One is going to the top and one is going to the bottom, so the positives stay in the middle on this. So the shorter negative leg goes up and down. And again, rather than have these sticking up in midair, I'm going to go ahead and bend these both down once I've got them to a reasonable position. So maybe these can go slightly off the board like so. This one, again, negative, going southbound in this case. And there we go. So let's just make sure that negatives are going in the right direction, especially since I had to double check that one there. Drop the board. Okay, so negative towards the top and negative towards the bottom. So that looks good. And let's solder these in place. Okay. Very nice. Let's just trim off these legs. These ones are quite long. Okay, so what's next on our list of instructions? Carefully solder the transformer into the correct 5 holes. So this is our transformer. As you can see, it's actually got 5 legs. And again, if we look at the diagram, the transformer goes here, so it only goes one way round. The 2 legs that go towards this pale blue transistor, capacitor even, these ones go like so. So it's getting a bit easier now. I've populated some of the board to see where things go. So there's our transformer, nice and flush against the board. It's kind of loose though, so I'm going to use some blue tack here to hold it in place. Okay. So when I'm tinning the iron there, the purpose of that is not to apply the solder to the joint, it's just to improve the thermal conductivity of the tip. Okay, so I'm reasonably happy with all of those. I'm going to trim the transformer legs down now, so the transformer is now neat and tidily flush to the board. Okie dokie. Okay, there we go. Very tidy. So now we have checked the transistor leads carefully against the diagram. Make sure you can identify which is collector, base, and emitter. Well, we're going to use our transistor tester for that to be doubly certain. And when we identify them, solder each leg into its correct hole on the printed circuit board. So in this case, we're expecting some transistors, and I think if I look carefully at these ones, these are C735, and let's just double check, is this one also 735? I would expect them to be the same. Indeed they are, and this should be an NPN type transistor, and C735 is an acceptable one of the alternates they provided in these kits. So we can pop this in our transistor tester like so. Make sure we get each lead in a different socket. I just chucked that one around the room, but I did manage to find it again there. So let's see if we can get all the legs in. So they've been trimmed at kind of a different length, so hopefully I'm making good contact there. Let's see how that comes out. And there we go. So 1 is our collector, 2 is our base, and 3 is our emitter. And again, my transistor tester is rebooting, but let's take this out. So collector is 1, base is 2, emitter is 3. And these are identical transistors, so we don't need to test the other one. But yeah, let's do so anyway, just to make sure that this one is also functioning. And the same, collector, base, and emitter. Okay, good. Now, if we look at our diagram here, we should have the collector, which was in pin 1, so that's the socket 1, that's the pin to the left. Base was 2, the second one along, and emitter there. So that is indeed the expected layout from the diagram. And we can pop these into the 2 holes if we look at our diagram here. So this goes in here, if I can wiggle all of the legs in. And again, I made a note about this last time, but if I am not mistaken, it says keep the leads as short as possible, except transistor leads, which will be kept as long as possible. So again, I'm going to follow that guidance, even though that isn't what I'd normally do. But again, these are old transistors. I've not replaced them. These are the original ones from this kit. So I'm only going to put them down far enough that I can get all of the leads in. And I'm going to then, I'll trim them to equal length so they're nice and stable, but I won't be unnecessarily shortening the leads. So let's try and hold these in place there. Yeah, like so. And then this other one goes in this orientation, as we can see here. Bit of a weird stretch they've done on the legs here. I do wonder if people, especially the previous owner of this kit, might have thought that was actually necessary, because some of these leads were bent into some interesting shapes, or if that was just an accident. Anyway, again, this is the other transistor, so just want to provide just enough blue tack here, because I want to keep the transistor as long as possible. So actually they're going to probably be the thing that is the tallest component on these boards once I'm done. Okay, so again, we're just going to clean off this tip. Okay, so I'm going to alternate between the transistors to try and avoid overheating. Let me just have a little look at that. Yeah, I'm happy enough. Let's take the blue tack out and have a quick look at the positioning, because of course I can tweak them if I want to, but I think that's going to be fine. So I'm just going to trim off this kind of long leg. Actually, before I do that, I'm just going to touch that up with a little tiny bit more solder. There we go. Yeah. So the electrical connection there was probably just fine, but I'm just being a little generous on these boards. Okay, good. And the transistor's nice and cool, no problem at all. Okay, so it says solder the ends of the 2 red wires marked into the holes marked SP. Solder the ends of the other 2 red wires into the holes marked SW. So that's interesting. So it says red wires, but actually the original kit here did come with blue. And I've actually prepared some more blue wires because I didn't actually read this document before I've started. So we're going to go ahead and use some blue wires. As I mentioned, I've prepared some replacement blue wires, and I did some in blue intentionally to match, but it turns out that maybe I should have selected red. So I've also cut some short ones like they've done here. So I don't have this light shade. Now I know from the previous kit, and actually from disassembling it, that because of the speaker position, it's likely that the board will be quite close to the speaker. And so I'm going to use these shorter wires for the speaker. And these longer wires are going to be on the switch, which is what was the case before. And that might actually explain why they're the wrong colour, because we'll see actually how I suspect the previous owner had this assembled, at least for their purposes. Okay, so we can go ahead, and I've not tinned these yet, so I need to just make sure they're all twisted together and tin these wires. Okay. That one was a little bit more stubborn than the previous ones, but all tinned now. So, as I mentioned, we have the speaker as well. I'm going to put the short wires on the speaker. Okay, and hopefully these will go in, and if they don't, we can of course get some longer ones. So these are supposed to go in S and P, which is these locations here, which are coming off the transformer. So one of them is just behind that capacitor, and the other one is just over there. So yeah, I think that could work pretty well when it's in the case. So I'm going to leave that for now. And we have to wire in the other wires for the switch, which goes in the SW connection. So we've just done the speaker, now we're going to do the SW. And again, I'm going to connect this up to the switch first. Yeah, and then we'll solder to the board. I will actually connect these afterwards because that is what the instructions do say. So now we have a push button switch. And this needs to go in the S and W holes here. Now this is lighter, so I'm going to put this one in first. So S and W. And I think this will be fine. Just clean our iron here. Okay. Looks okay. And if we look here, we are also supposed to be soldering in the speaker. But if we look at the next line of instructions, we can see that actually the next one is to connect the battery clip, this battery clip here. And I think it would be better if we do this first, because again, this is another light thing and I don't want the speaker to be ripping putting weight on the board as I'm just finishing up. So the last instruction here is to attach the battery clip after we've done the the battery after we've connected the battery clip. So I'll do the battery clip, then I'll do the speaker, and then hopefully we'll be done. So this is marked positive and negative here, and red is hopefully positive and black is hopefully negative. Okay, so black to negative and red to positive. Let's make sure that is through. I'm going to do the positive wire first because that one's going through a little bit easier. So let's just make sure that's soldered in nicely. And then this black wire, it's got quite a bit of give in it, so Just make sure that's going through as well as it's going to. And there you go. So he doesn't need a lot of pressure or anything on a joint, but there we go. That's nicely set. Let me just trim off those excess wires as well. Okay, nice, very nice. Now the final thing we need to do, as I mentioned, is, because I skipped over it, is to attach that speaker, and the speaker goes between this plus and between the capacitor here, just on the other side of the transformer, and that's these holes here. So we can pop these both through. Okay. And okay, so again, I think those are fine. And there we go. So now we've done all of the soldering we need to do. As I said, the final instruction is just to attach the 9-volt battery, and I have a blue Panasonic general purpose zinc carbon battery this time, just a spare one I had to hand. And let's see what happens when we connect this up. And with any luck, that's very, very neat, right? So we're just activating the multivibrator that these transistors represent, and we're making an interesting squeaking sound from the speaker here. So here's our project box. So just to finish this up, speaker can go in like so. And as I mentioned, I think that's why the shorter wires here make a lot of sense. I'm not sure if we can get the battery in. Maybe I should have thought about where that capacitor was going to go. Maybe a little more. But the one thing that I think was worthy of note is if you look on this particular project box, someone's nibbled out the space here, and that goes for this gap here, which is why I've left these on such a long wire. So let's see if we can in any way snap the back of this box on. Maybe not. Maybe it's a bit of a stretch for it. That battery's maybe a bit tall. But nonetheless, we can now actually have our button outside and our working product inside, and maybe a little bit of tape, or maybe some more careful rearrangement on that capacitor. Maybe actually extending the legs and moving it somewhere else off the PCB some way might actually give us the space we need to really fit everything in quite neatly. But just for now, I think that's pretty good. Yeah, and one last time. Okay, so thanks for watching, and I will see you in the next video.